All right. When we're solving square roots involving quadratics, and I will, as usual, I'll show you both. You can kind of pick and choose how you want to do this. But I want to show you even more with these how to use your graphing utility. We can do it algebraically, but again, we're going to be focused in on what we're doing here so we can see what's going on. That'll be interesting when they hear that online later. Let me show you how to do this using the graphing calculator first, and I'm going to write some steps in here with it too, so you can kind of see how it goes, but then I'll show you algebraically how to make this work for you. So we'll make a little room up here at the top. Should have plenty of room to get this jotted down. All right, if we do it graphically, what we're going to do is we're going to plug each side of my equation into the graphing calculator. So we're going to treat them like they're two separate lines or two separate equations. Okay? So I always make note on this that we're doing each side separately. It's not like I'm trying to stick it all in one line. So while some of you are jotting that, I'm just going to let you see what that's going to look like here at the start so you can see what I'm talking about. So for instance here, I would take the left side here, which is the square root of 12, and I don't have an n, so I'll just use x. And then my second line is just going to be the other side, which is just x. So I'm literally taking each side of the equation and making it its own equation in my graphing calculator. Because what the calculator will do then, it'll graph each of those lines separately, and we're going to see where they intersect. So just so we can visually see what this is going to work like, this point right here is what we're going to find, and that's going to be the answer. So if some of you are still graphing or have weird things going on, okay, this is what my initial screen should look like. And then when you graph, you'd see something that looks like this. And again, we're trying to find that intersection point. So here's how we're going to do that. Once I have that in the calculator, and again, let me go back to the y equals in case some of you are still getting set there. I'm going to hit second. I'm going to hit trace, which will get me a menu up that should look familiar. And we're going to be using number 5 on that, which is called intersect. So we're going to do second, trace. There's my calculate menu. And we've used lots of these. We've used 0, we've used min, we've used max. We're going to use intersect on this one. And typically, what you're going to be able to do here, now, I'm going to show you a couple of special cases where it won't happen, but normally, if you hit enter 3 times at this point, the answer is going to show up. But let me kind of show you what each enter is doing for us. First curve just means I'm picking any point on this particular curve here, this particular line. So I hit enter. Notice the cursor guy moves when I do that to the other line, because now he's on this one. And again, as long as he's anywhere on there, I can go ahead and hit enter. Now, if you want to make your guess better and you want to move left or right and have him get really close to where the answer is, that's okay. But even if you just hit enter at this point, and you're like, oh, so the answer is 3, 3. Huh. That's kind of weird. But then you kind of look at it for a minute, and you're like, well, wait a minute, 3, 3, I don't see 2 variables. You know, I just see 1. And you're right. So you'll notice in this case, and it'll be a little more obvious as we're going along to some of the others, this one's what's called a double root. Okay? It doesn't mean the answer is 3 and 3. What it's telling me is that my solution, I have a double. So my n value for this one would be 3. And if I look at that, that makes sense, because 12 minus 3 is 9, and the square root of 9 is 3, and 3 would equal 3. You're like, okay, but what if sometime I don't have, you know, a calculator to be able to do something fancy schmancy? Oh, yeah.
I don't think you were. And I did it the same thing.
Do you does your window screen look normal? Okay, If for some reason your window is different than mine when you hit window, and then we'll figure out what's going on with yours too. Somebody might have messed with it. If you hit zoom and go down to what's called standard, it'll put you back at the regular graphing size for things. That may help some of you. Now, let's see. So we were mentioning a minute ago, what happens if I don't have a graphing calculator? You know, what would I do in this case? Here's what you would do. How would you normally solve this? Well, I don't want this radical here. So what I would normally do then is I'd go ahead and I'd square both sides. Yes, even the n that's just hanging out by itself over here. The n and the n squared would cancel each other out. So my squared and my square root are gone. And we've talked before about how when we have something that has n squared for a quadratic, that's where the party's at. Everybody wants to hang out with n squared. So all you would do here is you would go ahead and we're going to move this n and this 12 to the other side of my equation. And then at this point, I could use the quadratic formula. I could factor it. I could do all sorts of things. Since it looks like it's a diamond problem, let's see how this works here. Can we figure out two numbers that multiply to negative 12 and add to 1? Okay. Positive 4 and negative 3. And you're like, well, hang on here a second, Harty. When we set those equal to 0, I get two answers. So why are we content with only getting one answer when it looks like there's two? Well, we always used to say before we had to watch to make sure both answers worked. Well, we already tested this one. We know that works. If I plug in negative 4, okay, 12 minus negative 4 would be 16. The square root of 16 is 4. Does 4 equal, negative 4? No. So if you do it algebraically, which you can, always double check and plug your answers in to make sure they work, because sometimes they may both work, sometimes one may work, sometimes neither of them are going to work. But again, with the time that it takes to do that, I really think it's in your best interests when you're going to do these to go ahead and at least give it a shot while you're in here at doing them using the calculator. So for instance, if I'm trying this next one, so I'm like, all right, negative 24 plus 10x, I'll get that closed up. And then again, I just have x for my other one. So when I'm graphing, so I'm noticing like, okay, it's somewhere in here somewhere. Here's what I've got to, again, be a little cautious of. So, go to do my trace. I'm going to look for my intersection. Now this time, I don't even see the little cursor guy anywhere. I'm like, what the heck? There's no y value here. If you move back and forth a little bit, now you'll see him show up here in a minute. I'll explain why it took him a while to show up. Okay, why did it take him a while to show up? Because when I plugged this in originally, this square root problem didn't start at 0. Okay, it shifted, which made it be in a little bit different of a place. So when I went to do my intersect, if you don't see a y value right away, use your left and right arrows until the little guy comes up here. So he's on this curve at the bottom. And again, we can just hit enter anywhere for that. My second curve, notice, if you move the little cursor guy back and forth, now he's on the line, the straight line. Anywhere on there is fine. And then I'm just going to hit enter, where I kind of think it looks like they're going to intersect. Now, here it says they intersected 4, 4. Now, does that mean that might be my only answer? Maybe.
Wait, what did you get for your graph?
Uh-huh. And also, if some of you, depending on where your cursor guy went, you may be getting a different answer originally, but stay patient because there's going to be a second answer this time. When we got 4, 4, when we graphed this originally, okay, we're going to put this here for now. Because again, it's the x value I'm looking for. So that's what I'm on the lookout for. But I need to make sure there's not a second answer. You're like, oh, gracious. So if I'm wondering if there is, I'm going to get the intersect going again. Again, as long as I'm somewhere on this curve, that's fine. Doesn't matter. Okay. My second curve, again, I'm on this line that's going back and forth. You're like, oh. So wait a minute. So supposedly right now it looks like my answers are 4 and 6. Now how am I going to be able to tell when there's two answers or not? Because it's kind of hard to tell on that line where that curve and that line are intersecting even. Okay, there's a couple of things I can do. I can either just play with it like I just did and move my cursor guy a little further and see if that works. But we've talked a little bit before about zooming. Now if I want to zoom in a little bit more, okay, I can zoom fit, which makes sense. I want it to fit to the graph that I'm doing. Now, it didn't zoom in a whole lot, and these points are so close together on this one, it's kind of tricky. So if you're not sure sometime, this is where I use my other tool as my backup plan, where I say, okay, I think I've got the answers, but if I need a backup plan, I always can go ahead and do it algebraically. Get everything to the x squared side, and again, it's on the opposite side of the equals. So I'm going to do opposites to get it over. And some of you may find that you just like this way better. You're like, yeah, I don't like messing with all that stuff and hitting a billion buttons on the calculator. I would rather just say, okay, what multiplies to 24 and adds to negative 10, negative 6 and negative 4, and I set those each equal to 0, and I get the same two answers. And again, I can just do a quick plug-in to make sure they work. 10 times 6 is 60. 60 minus 24 is 36. Square root of 36 is 6. Equals x, 6. Okay, that one worked. 4, 40. 10 times 4 is 40. Minus 24 would be 16. Square root of 16 is 4. Okay, they both worked. So again, it gets a little bit, and number 2 is more the exception than the rule on what this would look like as far as these go. Most of the time you're going to get a real clear picture of what these are going to look more like. All right, let's see. Let's try one more, and we'll see if we can go, if we want to go both ways with this one or not. So 65 minus 7, and I just use x, and then x minus 11. All right, let's see what this looks like graphically. You're like, now these don't look like they're going to intersect at all. And I'm looking, I'm like, maybe I'm just not seeing this out here. Maybe if I move my window over a little bit. Let's see. Because that just seems weird. So if I move it, and I'm just going to shift the one thing with my x. I'm just going to play a little bit. Oh yeah, that just doesn't look like they're going to cross. So initially I look at this and go, this might be no solution. I'll even try doing my intersect. Let's see if the calculator agrees. Okay, so there's my first curve, the curve up there. Here's my second one. Yeah, it says error, no sign change. It basically means there'd be no solution. So I'm like, okay, for the time being, this looks like no solution. Now those first two that we've done look pretty simple as far as, okay, I'm just squaring both sides, I'm doing a diamond. It's not always going to be that simple, which is the other reason I want you to see how the calculator may be a better choice here. So check this out. I have to square both sides, and we knew that already, because I got to do that to get rid of the radical. So like, okay, 65 minus 7k. Oh, I have to FOIL this out. So I can't just do k squared plus 121. That's not how this works. What I'm going to do is I'm actually going to FOIL this out, because that's where my squared term, my quadratic term, is going to come from. So again, I do my first and my outer and my inner and my last. And I'd simplify this up, combining my like terms, and that's going to be the right side of my equation. Now, the positive thing to think about here, well, at least it's just a k squared, so it's not like I'm going to have to do slide and divide or some crazy thing like that. I'll get that back down here just a second. There we go. Just give me a little more room to work with. The rule will still be the same. I'm still going to move everything to the k squared side. So here, since it's on the opposite side, I do have to do opposites to get it where I want. And then I would just do the diamond. You're sitting there going, well, wait a minute. This looks like this diamond can be done. Multiply to positive 56 and add to negative 15. 8 and 7, they both would be negative. And you're like, well, if I set those each equal to 0, forget no solution, I get 2 answers. But remember, when you're going to test these to see if they work, if I plug in 8, 65, 7 times 8 is 56. So let's see. 65 minus 56 equals 8 minus 11. Because again, I'm just plugging it in for the variable. This would be the square root of 9, which is 3. 8 minus 11 is, oops, negative 3. That didn't work. Well, let's try the other one out. Maybe that one's going to work better. So I get to that one, and I do the same thing. I plug in the 7 for k there, so I'm like 65 minus 7 times 7 is 49 equals 7 minus 11. That'd be the square root of 16, which is 4. Oops, equals negative 4. That one didn't work either. It's no solution. So again, if you ever get frustrated or confused playing with the calculator, that's your outlet, okay? You can always go back to just doing it with algebraically. Nothing wrong with that. But the one thing I gotta warn you of, with any of these, okay, you wanna make sure, and this especially will be the case when we go to the calculator, we always want to isolate the radical before we start doing anything else, in case, of course, we want to go to the algebra as well. So here, before I go popping away into the calculator, I'm going to go ahead and get this situated so my radical is isolated, because if I have to do it algebraically, that's going to make my life easier. Swing this over, and again, we'll take a look at our options. So let's see here. Minus 2. And it doesn't matter which order I do them in. If I do the radical up top or the bottom, I'll get to the same thing at the end. But I do remember, I think I got to put my window back. Yes. And again, if you don't remember, if you don't remember how to put your window back, you can always go to the zoom menu and just go back to standard. Standard will get you back to negative 10 to 10.
How do you get that?
On how to get it back to regular? Yeah, if you hit zoom and you go down to number 6, like if you changed your window for some reason on a different problem, you can always get it back to the normal box by just going to number 6 on the zoom menu. Yeah. And this one I start to look and I'm like, okay, that looks like my only intersection point, because this is like that other one. Stop, it's starting right here and it's not going all the way down. So that's my spot. Okay, let's get there. Looking for the intersection. Okay, my first curve is anywhere along this straight line, so that's fine. My second curve is anywhere along that curve that's up above.
I didn't get a curve.
Did you get your radical in on one of them?
Yeah.
We're going to have to take a peek here.
Oh, I did 3K minus 2. Does that matter?
Yeah, I was going to say, if it's not the X, it's looking at it as like a letter of the alphabet instead. So I bet you that's it. And I'm wondering for some of you if that's how some of the things have been getting. I'm going to have to check this out. So let me get my curves back here. Now again, when you get here, these K or these other values, these are my X values as I'm going along. So it's like, okay, I got one at 6,4. Does it look like it's crossing anywhere else? No, but let's see when it says 6,4. Let's see if both of these work. Let's see if either of them work. So if I plug in 6, call it K here. So 6 minus 2 would be 4. 3 times 6 is 18. Minus 2 is 16. And the last I checked, square root of 16 is 4. Okay, so that one worked out well for me. Let's see here. And this is where we get to see, and hopefully I have it click with some of you that it's not both of these. It's just this X value that I'm looking for. Because if you'd have tried the 4 as well, which again, I'm not suggesting, it's just that first value, you'd be like, well, 4 minus 2 is 2. 12 minus 2, yeah, the square root of 10 doesn't equal 2. That's not any good anyway. So this one, it's that 6. Algebraically, I can do this. Yeah, the 6, the X value is the only value you're looking for when you're using the intersect. I think we even need to make a note of that up at the top because otherwise we're going to wonder sometimes. Okay, your X value is the solution. Okay? We're not trying to take both of these values and turn them into something somehow. It's just that X value. And if it looks like there's two places they intersect, you can test that out. But otherwise, just make sure. And again, I'm foiling this side out. I'm just kind of helping out with some time purposes here. But it's like when we foiled it out over in number 3. The other side, I just lose the radical. And then again, I'm going to subtract the 3k over. I'm going to add the 2. And again, I could factor this out. Negative 6 times negative 1 is positive 6, but they add to negative 7. And like we've seen before, I get 2 answers. But again, when you plug them in, we already know 6 works. We checked that before. But if I want to check out 1 this time, I go, okay, 1 minus 2 is negative 1. 3 times 1 is 3. Minus 2 would be the square root of 1. But negative 1 doesn't equal 1. That one doesn't work. So you've got lots of options to make sure that you're getting these right. And that's the part that I'm going to keep stressing with all of these. Whenever you're doing them, and again, make sure that your radical is isolated. This is going to be the last one we're going to tackle on here. And again, algebraically works. Or I can just type these in. And again, I'm just going to keep using x for whatever the variable is. So if that drives you crazy, you can even change everything into x's on your sheet if you want to. Again, make sure with your radical you get those in there. That looks good. Looks again like I got one intersection point right about there. So second trace. We're going to intersect. And again, anywhere along this line is fine. I see that's the straight line. I see the second one's my curvy guy. And it looks about like the intersection. And again, it's not the 5 and the 2, it's just the 5. The nice thing about the calculator is if you get an answer on the calculator, that's it. You won't have to check it because that's graphically showing you that there's a solution for this. Whereas if I do it algebraically here, I got to always make sure that one of them is going to work for me. Yes, sir? Number 5 on the notes. Okay? And so all we're doing with these is the intersection gives us the x value. And I'm just going to keep stressing, it's the x value. The y is not helping us at all. So when we're also working with these when it comes on to the practice. Now, I'm going to tweak this a little bit. I didn't want to say this at the start because I know how some of you take off and jump ahead on me here. So when you're onto this, and again, it may look different on yours. If it does, flip it over. That's where you'll start seeing what it looks like the one I've got here. This is our last assignment in homework check 9. You can use it either way. I'm not worried about sketching a graph of the edit. No, just get to the answer. But on these, I want to make sure before I open my mouth and say this. Yes, this is what I want to do. The evens on this, both sides, okay, are the actual assignment. I want you to get some practice, but we don't need overkill. If you want to go ahead and you're having fun, you're playing with the calculator and stuff or whatever, and you want to do the odds, you can get some extra points. But just keep in mind our schedule for this week. So you've got this to work on. You got the unit review that you've got. Tomorrow is strictly going to be a work day. So whether that's working on this, the unit review, whatever it happens to be, Wednesday we'll go over the unit review fully. Answers will be up, questions will be taken, all that other stuff. And then Thursday's the unit test. So make sure whatever it is you're working on tonight, it's something, because this isn't the time to procrastinate. Because tests kind of can hurt a little too hard if you're not on top of things with those.